This is part 2 of section 9.1. We're now going to talk about our second method for solving a quadratic equation, one that will give us irrational answers and complex answers. This is called completing the square. And to be perfectly honest, this is no one's favorite method for solving anything. But there are topics in college algebra that you must use completing the square on. There is nothing else that will work. Now, so what I'm saying is completing the square is used for solving a general quadratic equation, but most people tend to avoid it because you have other options a lot of the time. But when you get to especially circles in college algebra, you're going to have to use this. There's no other way to do it. Okay, so let's talk through this. We're going to start off with a general quadratic. Notice we have the 0 here, we have it in this order, and notice your A, B, and C go in this order. Okay, now our first step for completing the square is to divide everything by A. So what we're going to do is we're going to take whatever number is in front of our x squared, and we're going to divide everything by that value. We need a 1 in front of our x squared before we can do anything, most of anything else, okay? We also want to get this constant on a side alone, and it doesn't really matter which of these two steps you do first. So if your C value is over here, which eventually we're going to want it over there, we can still divide everything by A. Or we can divide everything by A and then move our constant over to the right. But those were our first two steps. Okay. Now, after that, those two steps have to be done before anything else works. Okay. Now what we're going to do is we're going to do a little calculation off to the side, and we're going to find what I call the magic number. We're going to take the coefficient of x, so after we've divided and everything, whatever number is in front of our x, we're going to divide it by 2, or half it is another way of thinking about it. Dividing it by 2 is easier for people to understand if we actually have like a regular number, a whole number, and half it makes more sense to people if we happen to have a fraction. But it's the same thing. Anyway, we're going to take this coefficient, we're going to divide it by 2, and then whatever answer we get, we're going to square it. Okay, and that's going to be our magic number. So, for example, if the coefficient is, let's say 20, then we're going to divide that by 2 to get a 10, and then we're going to take 10 and square it to get 100. So our magic number in this case would be 100. Okay? We're going to add this magic number to both sides. We're allowed to add any number to both sides of an equation. Okay? Now, why I call this the magic number is because this is the only number we could add to both sides that would create a perfect square trinomial on one side. And then we're going to factor it. So what I mean is we're going to end up with something that looks like one of these two things, meaning it will factor like this. And if it factors like this, then we're going to have a square root property problem. We're going to end up with a problem that looks like these did originally. Okay? So let's start solving these by completing the square. Okay, so our first step is to divide everything by the coefficient of x squared, everything by A. Well, that number is a 1. If you divide everything by 1, it's still the same thing, so we don't really have to worry about that. Our next step is to move the constant over to the right. So that gives me x squared plus 4x. I suggest leaving yourself a little bit of space right here because we're going to be able to do our calculations off to the side to find the magic number, and then that just gives us a place to put it in there without having to recopy everything. And this will be equal to 2. Okay, so our next step is to find the magic number. And to do that, we take the number in front of x, which is 4. We divide this number by a 2 to get a 2. And then we take this number, whatever it is, and square it, and you get 4. Now, are you always going to get the same number back? Absolutely not. It happens with a 4, okay? And that's because 2 times 2 is 2 squared, okay? And we're always dividing by 2 here. So the magic number, though, is a 4. So I'm going to add 4 to both sides, okay? Now, if we've done this correctly, we should have a perfect square trinomial right here. And that requires perfect squares on the ends, which we do have. And if you take the square root of each of these, which would be an x and then a 2, so that would be 2x. If you take that and you double it, you get 4x, which is the middle term here. So we should have a perfect square trinomial. And I'm not going to worry so much about checking this every time, because this is always going to happen. And these things always factor in the form of the square root of this, whatever sign this is. It's a plus here, minus here, minus here. The square root of this, squared. And this is going to equal 6. Now we have a square root property problem. We have something squared equal to a number. So take the square root of both sides, and you get plus or minus 6. Okay? So we have x plus 2 is equal to plus or minus the square root of 6. 6 does not simplify in there. It's 2 times 3. There's no pairs. Now let's move the 2 over. So I get x is equal to negative 2 plus or minus the square root of 6. So your two answers are negative 2 minus the square root of 6 and negative 2 plus the square root of 6. Okay, so let's try this problem. The first thing we have to do is we need to divide everything by a 2. Okay, so divide by 2, divide by 2, divide by 2, divide by 2. This gives us k squared plus 5 halves k minus 1 is equal to 0. Now we want to get the constant on the other side, so I'm going to add 1 to both sides. I have k squared plus 5 halves k. Leave myself space here. This equals a 1. Okay, so you're going to get fractions with this. It happens all the time. What we do is we take our coefficient of x, whatever it is, which is 5 halves. We're going to divide it by 2. Remember how I said we also think of it as halving it? Dividing by 2 is the same thing as multiplying by 1/2. With fractions, it's easier to think of it this way. With whole numbers, it's easier to think of it as a division. And this equals 5 over 4. So I'm going to add 5/4. Wait, no. I half it, and I forgot to square it. 5/4 squared will give me 25 over 16. So I'm going to add 25 over 16 to both sides. Okay, so this should be a perfect square trinomial, and it will factor as the square root of k squared, which is k. This is a plus, so this is a plus. And then I have the square root of 25 over 16. Remember, you can take the square root of top and bottom, but it's always going to be this number right here, the number before you squared it. So it's k plus 5/4 squared is equal to, I'm going to do some calculations over here. I'm going to rewrite 1 as 16 over 16 plus 25 over 16. And this is going to equal 41 over 16. Okay, so this value is 41 over 16. Now I have something squared equal to a number. So I can take the square root of both sides, put the plus or minus here. So I get k plus 5/4 is equal to plus or minus. I'm going to think of this as two separate radicals. So I have the square root of 41 over the square root of 16. Well, the square root of 41 does not simplify at all, so I still have the square root of 41 in the top. But the square root of 16 is 4. Okay, now I need to move the 5/4 over here. And if you notice, they have a common denominator already, so I can go ahead and combine them. This is going to be k is equal to, when I move this over here, it would be negative 5/4. So I'm going to put negative 5 plus or minus the square root of 41 over 4. If this simplified in any way, I would do that, but it does not. Your two answers are negative 5 minus the square root of 41 over 4 and negative 5 plus the square root of 41 over 4. Now, this is a case, I want to point out one thing because it's a little bit different from the problem we're about to work. Notice how we ended up with one fraction here? We can do this as long as we do not have an I in our answer at any point. If we had needed an I in front of our square root, we would have to split this up into two fractions. And the next problem we work is going to be like that.